All right, so we're going to talk today about, where are we here? Test-driven development in Python. And what we're going to use, instead of Jest, we use Jest for JavaScript, which is just one option among many. We're going to use something called Unit Test in Python. All right. Okay, so Unit Test. So Jest is a third-party module for JavaScript, right? So it's not part of JavaScript itself. It's just some code that someone else has written and they've added it on, and you can download it and use it, right? Python has kind of another category. So there's the core language itself, and then there is this what's called the standard library. And the standard library the standard library has a whole bunch of specialized modules in it that you can use. And these specialized modules are not really, it's not really the core Python. It's not things like for loops and keywords and stuff like that. You don't have def and for and it's not the basic syntax. These are specialized things that are that the people in charge of Python have thought are important enough to kind of include with Python, but to not really be a part of the core of Python. So Python has core Python, then there's these there's the standard library, which is all these modules here. And then outside of that, there are third-party modules, which is just code that anyone can write, and then you can use it. So these modules, there's a bunch here. So this is, I'd recommend if you're interested in exploring Python standard library is, has lots of cool stuff in it. And here are some of the modules. So there's func tools. So if you're interested in doing functional programming, for example, there's a lot of basic tools in here which you can take a look at. And then, so for example, like dates and times, this is a, if you ever try to work with dates or times, it's a huge pain, and it's one of those problems that seems like it should be fairly straightforward until you actually start dealing with it. So there are some libraries here. There are modules that help you manipulate the file system. So we do commands like cd and pwd and touch and so on. Well, you can basically execute those commands and things like that using Python. So there are modules that kind of allow you to provide an interface for that. Okay, and there's a whole bunch of other stuff. So you can take a look at this. There's a lot of interesting things. If you have a spare moment and you're interested in something, I would encourage you to explore this Python module of the week. It's a cool blog. All right. So back to unit test. So unit test is part of the standard library in Python. It's, it's not, again, not core Python, but it's not just some random third-party library. This is something that, the people in charge of Python thought was important to include. And here is the documentation for that. So Python has its own official documentation. Yeah, you can look at tutorials, and that's great. And you can read books and do all this other stuff. And those resources are often better than the official resource, but this is the official Python docs. So you can see if you docs.python.org, and then make sure you're on 3 and the specific version that you're using. In most cases, if you're using 2, there's going to be a problem. If you're using 3, it's fine, but you might have issues if you're not on the right major version. Can anyone tell me? Can anyone tell me what this like this format is? 3.10.2.
Well, version 3 is like the major version number, and then every release comes out gets like added, incremented by 1.
Yeah.
And then if they do a fix on like version 10, they'll add the .2 at the end of it.
Yeah. Yeah, so this is kind of a standard, I actually forget the official name, but this is a standard format for versioning. And versioning, it's one of those things, again, it's one of those like bookkeeping things that when you first start coding seems just like uninteresting or maybe unimportant. But if you're trying to manage lots of dependencies in a large project, it becomes important. So 3, so this like first number here is what's called the major version. So this is like, you know, almost like a different version of the thing. So there are, you know, if you go from version 2 dot something to 3 dot something, for example, in the case of Python, then you can expect major changes. You should almost treat them as different things. And then here we have a minor version, the second number, which is 10. So if you go from Python 3.9 to 3.10, you should not expect, I mean, there are potentially some breaking changes, so you shouldn't just, you know, you shouldn't just assume that it will work, but you can basically assume that it's gonna work. And then this minor version is like a patch, so like a small bug fix or something like that. It doesn't really change, like basically no one should really notice it, shouldn't change anything. This is for like very small minor fixes. So that's basically the numbers. Okay, so back to this unit test. So it's always good to take a look at the documentation. So this documentation is fairly long, and do we need to read all of this and understand all of this in order to start using this unit test library? No, we don't. So we have a whole massive text, and we need to kind of parse this and pick through what we need to get going. So let's do that. So I'm going to open up a project here. All right. So I have VS Code open, and I'm going to create, well, let's take a look at the documentation first. So unit test is a unit testing framework. So what is a unit test? Anyone? Call on Melissa. What is a unit test?
Basically, I mean, it's a way to test your code without using like print or console log.
Okay, good. Yeah, so a unit test, so there are maybe some like ad hoc tests would be something like, you know, console log something and check it. And then a unit test is something a little bit more official where you're testing. So that's good. So what's it, but why is it called a unit test? If anyone, I'll ask Scott. Are there non-unit tests?
So I'm thinking that I'm honestly not 100% sure.
Yeah, that's fine. Yeah, I'm not expecting people to know. I'm just, you know, kind of putting a couple people on the spot to just, you know, whatever you think. I mean, you can take a guess. Okay.
It tests individual components, so like a small unit of the entire project.
Right. So you can think of in terms of like, unit testing. Unit basically means function. So if I have a program with a whole bunch of, in the real world, a whole bunch of different classes, right? And they're all kind of interacting with each other and doing stuff like that. Testing the entire system can be complicated, and complicated and hard to do and time consuming and all kinds of other things. So what you want to do is you have a huge complex system like, whatever, Facebook, like a huge web app. What you want to do is break it up in the smallest, you want to be able to test the smallest units, the smallest, piece of whatever you're working on. So that's what a unit test means, basically testing individual functions. So that's what a unit test is. And there are other kinds of, there's, integration testing and regression testing and end-to-end testing and stuff like that. So unit testing is the smallest level of testing. Okay, so it says that this was originally inspired by JUnit. So JUnit is the Java equivalent of this. So in Java, Java's been around for a while. Java developed a unit testing library, and so this is based on this. So you'll see this in programming all the time, where you can trace the influence of a particular thing. So it's not like someone just sat down and from the heavens, just the idea of unit testing and the way that this should be organized came down. This is usually almost always based on something else with some tweaks. So in this case, there's something else that already existed that was basically solving a problem, and someone said, well, let's just kind of port this over into Python. So I don't expect anyone to know Java. I don't really know Java, but so that's often. And if you learn multiple programming languages, you'll start to see that there are similarities. So humans develop programming languages, and those humans have experience with other programming languages and like certain things and don't like certain things, so on. Okay, so this is a testing framework. So to achieve this, unit tests support some important concepts in an object-oriented way. So here we already know something about, so we haven't looked at any of the code, we haven't done anything, but we know something about unit tests now. We know that it's object-oriented. So how would you describe Jest, the JavaScript framework we looked at last week? Is it object-oriented?
Probably functional oriented.
Yeah, it's a functional. Yeah, it's functionally oriented. So you use lots of functions. So you remember you have the test function, right? So that's a function. And inside that function, you pass in a string and then another function, right? And then that function calls another function, the expect function, right? And you pass in whatever, and then that calls a method, right? So you're chaining together lots and lots of functions. So that's a functional style, and this is an object-oriented style. So you can write an effective testing framework in either functionally or object-oriented. Okay, but that's how this is. So we're going to take a look at that. And there are some components here. There's a test fixture, test case, test suite, and a test runner. So we're basically going to be concerned here with test case. We're not going to look at every possible thing you can do with unit test. So a test case is the individual unit of testing. It checks for a specific response to a particular set of inputs. Unit test provides a base class test case, which may be used to create new test cases. So I don't think we've talked about, did you guys talk about inheritance at all? Okay, we'll
No.
That's fine. So we'll talk about it a little bit. So object orientation, there are some things that make it more useful, and one of those things is inheritance. We'll look at that in a little bit, but does anyone happen to know what this sentence means? Unit test provides a base class test case.
So the provided base case class is gonna have certain traits that we can then create new classes based on that, and it'll inherit the methods and any other traits that are in the base class, but we could also go modify them if we want.
Yeah, exactly. So a class, so you can think of a class as a template, right? So if I want to create, an employee or whatever, or let's say like a DMV application, right? So I want to, write a program that describes applying for a driver's license. So I write a class that says like, driver's license form, and it has, all the fields that I need. And then I give it to someone. I say, okay, fill out this form, and then I'll create an instance of a driver's license application. What a base class does, so there's something called inheritance, right? So inheritance kind of takes that concept of reusability and extends it another step. So you can have a base class, and then you can subclass, and that subclass will be able to use things in that base class. So this all sounds very abstract, and we'll talk about it more. But so if I have a DMV application class, right? Let's say I want to have a DMV application class, or like a driver's license application class, and a motorcycle license application class. So there's probably, so even though those are classes, right? And I'm abstracting a lot of stuff, so I don't have to, write everything every time I create an instance. There's still a lot of common elements between those, right? I'm still going to want people's names, still going to want people's addresses, and so on, right? So now I have two classes that have a lot of common stuff in there. So what I want to do is take that one step further and go a level higher and say, there's an even more abstract representation. Let's say we'll just call it an application, like a general application. And anytime I have an application, I want to make sure I get people's name and address, right? So then I can take care of name and address here in this base class. So the metaphors are often confusing with your high or low, but so we have this parent or grandparent class, which has say takes care of name and address, and then I will create two subclasses that will inherit from there. So now my driver's application, I don't have to worry about name and address here because I'm inheriting from that. So I can use whatever is in my parent class. In my motorcycle application, I can also use the name and address there. So it's just a way of, the ultimate goal is don't repeat yourself. And that's just another way of doing that. So that's what a base class is. And we'll talk more about all that stuff later. But this is just a general kind of first exposure. So when we write our own class, our test case class, we're going to inherit from test case. And I don't know anything about test case. We could look in the source code, we can look at the documentation. We're not going to do that right now, but I know that if I write a class and inherit from this, then I'm going to get all of this stuff for free. So everything that's in this test case class, which is a mystery to me right now, I'm going to get for free. And then I can add my own stuff or customize, basically. So test case is going to be, I'm going to get all of that for free. Okay. So here's a basic example. It's always nice when you get a basic example. So so there are a few things going on here. Would anyone, so I'm gonna assume that none of you have ever seen this before, which is fine. Can anyone tell me anything? Just pick something and tell me about it, even if it's a guess.
The first thing that's happening is you're importing unit test, that framework, to be able to use within the test.
Yeah, okay, so I have to import, so unit test is a part of the standard library in Python. So it's not something that I have to like specifically download or anything. So why do I have to import it? Is that really necessary? I thought imports were only for third-party stuff.
Is it so it doesn't get picked up as a dependency?
What do you mean?
So actually, never mind.
Okay. So yeah, so
Is it,
that's a good thought. So this is, I mean, you can think of when you import something, you can think of it as you're creating a dependency. So go ahead.
do we have to import things that are part of the standard library since Python's interpreted and not compiled, like as a
Yeah.
language, or?
Well, so you do have to import things that are part of the standard library, but it's not, it doesn't have anything to do with Python's compilation process. So it is, Python is an interpreted language. We don't need to, we're not gonna spend a lot of time on that, but the short answer is anytime you're writing code, the actual test you're writing is gonna get processed. So it's not like I write my code and my computer directly runs it. It gets processed. There are a few steps before it actually gets executed on your computer, but we're not gonna talk about that. But you do need to mark this. So Python could have it included all of the stuff in unit test directly in Python, and you could just use it directly, but it didn't and partly that's just a decision that the designers of Python made. So they took all these specialized modules and they basically put them in their own namespace. So you can think of a module as its own little like file or something like that. So if I want to use stuff, because the assumption is that if I'm just a general user of Python, I don't always need direct access to something like unit test or some kind of hashing library or whatever. So this is a specialized thing. So it's just a way of marking that. So Python could be different, but that's how it is. So let's try, I'm going to create, let's see. Well, we'll see in a sec that there's kind of naming conventions, but I'm just going to call this so I'll import. I'll save this and I'm just going to try running it. I didn't get any errors, so this works. Whereas, let me do, here's another library. So this Python requests is a very common library. We'll see it again. But this is a third-party library. So if I do, and I try to run this, I get an error because this module, which is a third-party module, I haven't installed it. I haven't installed it locally, so the interpreter doesn't know what to do with it. So this doesn't work, but unit test is fine because it's already like, you could think of it as kind of being like pre-downloaded. So it's there, but you just have to specifically call it out in order to use it. Okay, so that's the import. Anything else here?
Looks like we're creating a class test string methods and then saying it inherits from the test case class within unit test.
Yeah, exactly. So why are we marking it like unit test dot test case?
Because unit test is like the library and then test case is a class within the library.
Yeah. So we can see, let's see. Let's see what this gives us. Okay, so Python, I think one of the nice things about Python, it has very good introspection capabilities. So you can kind of, you can take a look. It allows you to look inside of itself. So dir is one of those things. So I'm calling dir, which is a method that basically tells you, it will list out everything that unit test has on it. So unit test, this module has something called base test suite, function test case, isolated, and blah, blah, blah. And look right here. We have our test case. So we can do this test case. We want to keep looking. So this is like, you know, kind of like documentation, but we can see that this test case class, which we're going to be inheriting from in a second using, has all this stuff on it. So there's a whole, so this is a class with all of these, you know, methods on it. And we'll talk more about what some of these are, but we know that we have stuff like assert, dict, equal, assert, equal. So when we actually, we'll actually use some of these in a sec, but you know, it might seem very mysterious, but these things are all there and you can take a look at them if you'd like to. Okay, so unit test, so I'm gonna go ahead and write this class out. So test whatever, we'll go class, we need this keyword, and test, well, we're gonna have to have something to test. So we're gonna do the credit check problem. So we're gonna solve this and write some tests for it. So and I'm just gonna write a method real quick. Def So this is just something to get us started. So we have this test. We're going to be testing our credit check. It'll end up being a class. And we're going to inherit from unit test dot test case. And this is the, so what is pass? Have you guys seen that before?
It just keeps the little red squigglies from showing up while you're working on everything.
Yeah, basically, it's just saying like, this is still a work in progress. So you could just do something like this, but you might have issues. I think I probably need to install a couple things, but so pass is just a way of like, just let this work, don't throw an error, but this is kind of a placeholder. It's like a placeholder, but telling your code not to throw an error. Okay, so we have this test case, which inherits from this. What is this thing? So it's not immediately obvious, but so this is something that you can include and basically will distinguish between if I'm running this file directly. So if I do like Python unit testing.py, then this is internal Python stuff, but the property of this module will be main. Whereas if I'm importing this into something else, then it won't be main. So you don't really need to worry about that, but this is like a convention that you'll see in Python code a lot. It basically just means if I call this file directly, then run this stuff. So unit test.main. So we saw in unit test, do we have a main right here? So main is a function available inside this unit test module. So we can call that. All right, and then we have all these, what are these called?
Class methods.
Yeah, well, so they're methods. Are these class methods?
Instance.
Yeah, they're instance methods.
Because of the self.
Right. So the kind of default will be an instance method. What are the other two options?
Static method.
Right. So what's a static method? What's different about a static method versus an instance method?
A static method won't really have anything to do with the particular instance, or the class kind of just does its own thing.
Okay, yeah. So you can think of it that way. So why, I mean, why bother having, if you're writing a function that has nothing to do with the class, why include it in the class? So I'll say that some people think that, you basically shouldn't have static methods.
I guess it could be like if you know that a function should kind of be associated with maybe the name of the class. That's maybe why you would have a static method.
Yeah. So a static method is often used, the way it's used, it's usually like a helper, some kind of helper method. So it's usually called to maybe do some processing somewhere else. So you have one method that does something, and then that calls this helper method to make some calculation. But that helper method doesn't really need any information about the class or an instance. So it's a special case, and you don't have to use static methods. And but so so there's a static method, there's instance method, and there's class method. And you could think of these as basically answering the question, do I need access to something in the instance? If the answer is yes, then you use an instance method. If you ask, if the answer is no, then if you don't need access to either the class or the instance, then you use the static method. If you need access to the class itself, then you can use a class method. All right, so I'm just going to copy this. So there are a couple conventions. I'm going to speed up just a little bit here. So one requirement of this library, which is just a particular thing, is that you have to prefix method names with test underscore. So built in, there's a runner, and so this unit test framework is gonna do some stuff. It's gonna automatically do some processing. So you just have to you have to prefix your methods with test underscore so that we'll find them and run them. Okay, so I have this method. So what I want to do is test something. And so I want to test that this returns true. So how could I do that?
So that assert equal takes two parameters. So
yeah,
it's testing if one is equal to the other. So for the first parameter, you could call the method, you'd have to import it.
Okay, so first thing we have to import it. So it's in another file somewhere. So we're gonna have to import it. So imports, there's some slight differences between JavaScript and Python, but same basic idea. So we'll do from file name. And import the method there. So I can tell just by looking at it and making an educated guess that something like this should work. So I'm calling this, I'm importing this function, the something function. I'm calling it here, and then I'm saying it should equal true. All right, so how do I run this? I could, there's actually a few ways you can do it, but I'll just call this directly. So Python unit testing.py, and we get some output here. So we have this dot. And so a dot will basically mean successfully ran a test. We just have one test, so we have one dot. And then this is just the separator, and then it tells us ran one test. What if I did false? Then we get an F instead of a dot. And it tells us that the test failed. So fail test something, which is our test name here. And here's where it is. So we see this main thing again, because I'm running this directly. It's main dot test credit check, which is this. And then I get this assertion error traceback. And it tells me that true does not equal false. So I got true here, and it doesn't equal false, and this assert equal is failing. Right? So even though it's a little different than what we saw before, it's the same basic idea, right? We will write a method or a function that will basically test that something is something else. And just like Jest had a whole bunch of matchers, what they called matchers, unit test has a whole bunch of these assert statements. Let me see if I can find them. So there's a whole bunch of these assert statements. Here's kind of a breakdown. So assert equal, not equal, true, false, is not, and so on. So you can, we have access to these more specialized assert statements as well. Okay, any questions about that so far? All right, so let's do credit check. Let's actually do credit check. So I'm gonna go here. Where are we here? So I'm gonna go ahead and I'm gonna fork this. So this is Charlie Platoon. I'm gonna fork this into my repo. It's forking over. Okay, so now it's here. So I'm gonna now clone this from my fork. I'm gonna get rid of this stuff. Git clone. All right, so now I have CD credit check, and I'm going to do the Python version. All right, so I can see that I'm in the Git repo now. And I have this spec, which I'm, I can look at for now, but we're going to write, unit test using the unit test library. So credit check, here's the actual output. All right, so before we get started writing anything, let's take a look at can anyone tell me briefly what this is?
You're gonna take a number string.
Okay.
And starting at the end, every other number, we're gonna multiply by 2.
Okay.
Then if that number we get is greater than 9, then we're going to split that number into 2 numbers and add them together.
Okay. So 1 + 4 is 5 in this case.
Correct. And if and only if we take that 5 and modulate it by 10, and then we take all those numbers that we get after adding the single digit numbers together. And if that number modulo by 10 equals 0, then it's a valid number.
Okay. Good. Yeah, good. So that was a very concise explanation. So that's how this works. We start with a string of digits, and then we do some processing. We have a couple different steps, and then we'll get an answer. Is it valid or not? Okay, so we're not going to write a function. We're going to write a class. So I'm just going to start that now. So class. All right, so let's plan this out a little bit. So what methods should this, what methods and properties should this class have?
You have to multiply by 2.
Okay, so
Every
one thing
other.
we're gonna have to do is multiply every other by 2. Okay.
And then if multiplied by 2, then if the sum of that number is greater than 9, then we're gonna, we need to split the digits.
Okay, and we'll do okay. So I think this is probably a good method. This is like an isolated chunk of stuff that's testable. This is the same, I think. So I think these are good candidates for methods. Are there any other steps we need to do?
We need to add the sum together.
Okay. So let's okay, so we'll sum all the numbers.
And then we need to test the modular, see if it's modular by 10 equals 0.
Okay.
And that's about it.
Okay.
I guess you could do one to say, is it valid?
Okay. Yeah. So we could,
Is valid.
yeah. So we could potentially do
Use
that.
that one up. Yeah.
Yeah, we'll keep this like this for now. Is there anything else that we should do? What about
But we need to, because it's gonna be a string, we need to convert it to a number.
okay, so at some point we're gonna have to do some casting.
Don't we have to specify that we start from the right? Or can it automatically do that?
So that's a good question. Any thoughts on that?
I would think when we do the multiply by 2, when we setting it up, we'll set it up to start from the end of the array.
Okay, so we have a
Or
string. So,
reverse it.
okay, so we could reverse it. So what data? So we have these functions. What data structure? So we're getting past the string of digits. Is that what we want to be working with?
No, want it to be numbers.
Want
in
to turn array.
a number array.
A number, yeah. So you can't just have numbers. We have to have a container for it now. So if we want to convert that to numbers, we could do an array. So maybe we'll have to convert.
So number array.
An array of integers. Okay,
Mhm.
that's another function. What about the reverse? Okay, so we'll say this is good for now. So these are the methods that we need. What about properties? So class contains, has methods and data.
Need to take in the number.
Okay, so the so we're going to need a string of digits, presumably.
When you say properties, you mean like the stuff that's being input by the user?
So that's one. So one way of getting So how do I start off with some properties? If I want to create an instance of credit check and I want it to have this string of digits, how do I implement that?
That'll be an argument of the function, right?
An argument of what function?
Well, I guess like when you do the init, you know, you
Okay.
do the self,
Dunder in it.
do the.
Okay, so dunder
the
init.
digits.
So tell me about dunder init.
So in Thunder init, we can specify the requirements of that class. So these
Okay,
are
so right.
required to be entered or it won't work.
Okay, so that's true. So
So
init.
if I put, I'm sorry, go ahead.
So init. So any of these dunder methods are basically like Python. You can think of them as Python internals. So this is stuff that Python will use internally. You know, again, Python is very flexible, so you're kind of allowed access to that. So you can play around with it. But under the hood, Python will, when you create an instance of a class, Python will run a series of steps. So it's actually going to call a couple different methods, not just init, but we'll just worry about init for now. So it's actually going to, you know, call init. So what we're doing is we're actually overriding this init. So Python will call it even if we don't explicitly supply it, but here we're overriding that because we want to, this is a customization that we want to do.
Correct.
So self, and then we'll just call this, I'm just going to call this digits, may not be the best name. And then how do I make digits a property of?
Self.digits equals
Okay.
digits.
All right, so I'm gonna go ahead and just do a quick ad hoc test and see if this works. So how do I create an instance of credit check?
Create a name for it, whatever you want to call it, like my
Okay.
credit check equals credit check. Open parentheses, and then you input your string of digits.
Okay, whatever this is. And then if I want to just take a look at the digits property of this instance.
You can print CC dot digits.
All right, here we go. Let's run this. And we get 1, 2, 3. So looks like this works.
But it's still a string, it's not a number.
Right. But we can successfully, so I'm just doing like an intermediate test just to make sure that what we have so far is not obviously broken. So we have a class, we've implemented this init method, and now an instance will have this digits property. Okay. So that's good for now. Let's go ahead and I'm going to go ahead and stub out these methods and then we'll start writing some tests. Def. Let's see. And then we multiply. Any questions about what I'm doing?
No.
Let's see, do some numbers. Why am I including self in all these?
So
It's an instance variable and not a class variable.
Yeah. So what is self?
Makes it available to the whole class, to all the instances of the class.
But so what is self here?
It's a reference to the instance.
Yeah, yeah. So this, you can think of this as kind of a placeholder.
Okay.
So we can take a look at, okay, so yeah, okay, I don't want to get into that right now. But so we have this credit check class, and then we have our init method, and then we have kind of these stubs for these other methods that we're going to have. And right now, these are all instance methods. We could talk about, you know, how we want to design this. Do these need to be instance methods or not? I don't know. Let's go over here, and I'm going to create a new folder. So let's do and I'm going to follow this documentation. I'm going to import unit test. I'm going to create a class called test credit check, and that is going to inherit from unit test dot test case, this class that we know about. And I'm going to write a test, and I know that I have to prefix my test methods with test underscore, and I'm going to do we'll start with that property. We'll just test that. So digits. All right, so I want to test this. So where do I go from here? Ka. So here I am, I've written this method, this test. I've started to write this test. What should my next step be here? So we know we're gonna have to write in a assert statement, right? Kyle, are you there? Not there? Okay. Let's try George. George, are you there?
He said in chat that he's here, but his mic's not working.
Okay, okay, that's cool.
I can jump in. So we have to set some assert statement. So I don't know what the digits is checking for, but
One sec. So I might, if people are not actually here, I might have to implement like a cameras on thing. Don't necessarily want to do that, but let's try Sam. Are you there? Oh, actually, yeah, never mind, Sam. Will.
Yeah, I'm here.
Okay. Let's see. Okay, so I'm here. I've got my this method test digits property. So what's the next step I have to do?
You talking to Will?
Yeah,
Can you do a split screen of the test and the actual code that you wrote?
sure.
Thank you.
Let's go over here.
So we're gonna have to test that digits are getting passed. I don't know if we need to test that it's a certain length.
Okay. So, okay, so we're gonna have to write some kind of assert statement, right? Because these tests expect some kind of assert. So all of these have self.assert something. So we could start with a self.assert equal. So self.assert equal. And what do we want? What do you want to test? So we have.
So we need the name of the. It's credit check, right? Credit check. So we can test.
Yeah, I'm gonna stick with Will. So Will,
Okay.
you've got this test assert equal. Assert equal takes 2 parameters. So what do you want to test? We're testing that this digits property. Yeah, we're testing this property.
So we'll pass in digits.
Okay. Just like.
Can you show the unit test again?
Here's the unit test and here's the
I
code.
mean, the documentation.
So it just takes 2 parameters and tests that they're the same thing. So we could do something like.
So we could pass a couple of numbers, dot digits, and then make sure that's equal to the same numbers.
Numbers dot digits.
Yeah, so like 1, 2, 3.
Okay.
Dot digits.
Something like that. So the issue is that we have to have access to. Do we have access to credit check in this file right now?
No.
Right. So we don't have access to it, so we're gonna have to import it. So from. All right, so now we have access to this class right here. So we're importing this into here now. So now we can use this here. So if I want to test this self.digits property, Michelangelo. I see you're unmuted, but I. Anyone else hearing that? Very strange.
That was pretty bizarre.
Yes.
Okay.
Yeah.
Speaking too fast.
Voice modulator. Yeah, that's weird. Let's go with William.
So I want to say you would just do over in the unit test, you would do like I guess you do credit check dot convert string to list, or
So we just want to test this property first.
Just test that as there. Okay. So I guess you could do
So what do we do? I deleted it, but can anyone else help me out here?
would you have to make an instance first?
Yes, exactly. Yes. So we are going to have to create an instance of credit check. So I'm going to do that right here. And I need to pass it in some kind of string. We'll just do that. So now that I have an instance of credit check, what do I also have?
The digits.
Yeah, exactly. So how do I access this instance's digits?
CC dot digits.
Okay. And I can do assert equal something like that. Should be 1, 2, 3, and I'm going to run that test. Okay, so what happened there?
You're missing the main call.
Yeah, so there were no errors, but nothing happened. I basically just defined this test, but it won't run unless I do this part right here. So let's try that again. Okay, so now the tests run. And I have one test and it passes. All right, so that works so far.
Sorry, I have a quick question.
Yeah.
Just so I understand. So CC equals, that basically goes back into your credit check.py code.
Yeah, so let's trace this. So someone help me trace this. So let's start with CC and work our way back.
CC is a variable.
Mhm.
You're assigning it credit check 1, 2, 3, which is imported from above.
Right. So we start here. We're declaring or creating an instance of this class. This class is being imported here. It's being imported from this file. This file is over here, and the class is here. So we could just copy and paste this class and put it in here and then not have to do the imports, but it's basically like an organizational tool.
Sorry, and then I have another question. So then, just so I understand, it's like we're doing what we did before by just running a number through class credit check, and it's just going through the self.digits equals digits to print off 1, 2, 3. Is that correct?
So what we're doing here is we're creating, so this init method, where we're saying, hey, if you want to create an instance of credit check, you have to give me this parameter. You have to give me
Right.
something here. So when we create this instance, this 1, 2, 3 is going to be this. And so when we create an instance, we're passing it here, and then we're saying, I want you to assign whatever you get here as a parameter. This could be called whatever we want. I want you to assign this parameter to an instance property called digits, which is what we're doing right here. So CC is the instance, and we're saying, this is like self.digits.
Okay, and since we set CC to 1, 2, 3, that's why it's CC.digits is essentially 1, 2, 3.
Yes, it's whatever. In this case, it'll be whatever we passed in. So if we passed in, an integer or whatever we pass in, it is going to be what this is, because we're just taking this and directly plopping it down and assigning it to this.
Got it. Thank you.
All right, cool. So let's take a 5-minute break, and we'll come back and resume. All right. All right, so we're back here. We've got our first test written, and we have basically a skeleton for our credit check class. So should be fairly smooth sailing, kind of repetitive from here on out. So we're going to start knocking out these methods. So we have a couple kind of design questions to answer. There are a few ways we could create this credit check class. So we have this init dunder that we're overriding. So now we have access to digits. And so this means that we have access to digits anywhere, right? So if we want to start processing this, let's say convert string to list, this first one. How should we, so what do we take in and what are we going to return?
You're gonna take in digits and return a list of those digits.
Okay, so it's a little tricky with a class. We have a couple options. One, we don't really need to take in as a parameter this because this is an instance method. So we have access to self right here. So we have access to self.digits kind of already here. And then if we return, so let's say we return an array or a list, we could do that. What are the rest of these methods going to need?
That same array?
Potentially, yeah, potentially. So I just want to introduce the idea that there are a lot of ways we could do this. So one thing we could do is we could actually return an array here. And then when we call other methods, we just have to kind of save this value wherever we're calling from it. So externally. So for example, we would do, in this case, we would do create an instance, assign it to this, and then maybe do something like converted equals cc dot convert. And then when we call the next method, we would just pass that in as a parameter or something like that. So we could do that, right? And that will be fine. Is there another way we can do this? Not necessarily saying that one of these is better or worse, but is there another way we can do this?
You can save that internally under the init.
Okay, so we could create another instance attribute, another instance property called.
Could you?
Yeah, go ahead.
Well, could you push it to a class variable? So then would every other instance then have access to it?
Okay, so that's a good question. So what is a class variable?
Isn't that, if I remember correctly, it's the variable you would put essentially before the dunder init that, and this is where I might have been confused. I thought everything then had access to it. It was more global then.
Yeah, it is. So can someone explain this? There's between a class, like say a class property,
So,
instance property.
So like a class variable would be accessed by anything that uses any credit check, and it'd be the same data. So if you had 1, 2, 3 in there, all of them would have 1, 2, 3. They aren't individualized.
Yes.
Oh, okay. All right.
So that's correct. So then the question is, do we want that? Do we want, let's say, digits to be a property of the class, or do we want it to be a property of each individual instance?
Each instance is my guess, not the whole class.
Yes. Yeah. So another way of thinking about that is, do we want this to change? Do we want this to be, let's say, unique for every single instance? So if we made it a class property, it would be the same for every class. So basically, in our case, that wouldn't work because we would only be able to test one string of digits. So in this case, we want every single instance to have its own thing so we can test it and run all of our tests. So we'll create lots of, we'll have as many instances as we have digits or strings. Okay. All right, so we have this here. So this converts string to list. So we're talking about creating another instance property. So we could, how would we create potentially another instance property?
Well, it'd have to be in the dunder init, right?
Okay, that's a great question. Does anyone know the answer to that?
Actually, maybe not, since, sorry, that's an instance method. So I suppose it would have access to itself. But you couldn't do it with, or I guess you could do it with parameters. So I guess you could just do it that way.
Yeah, so we could do something like pardon the long names, but just trying to be clear. So we could do something like this. So we can convert this string to a list. There's a couple ways we can do that. We could actually just call list on the that will just give us a list of strings actually, which could work for now. So we could do something like that. And after, so it's a little bit confusing, but once we call this method, this class will have this property now, and it will be accessible anywhere else. So even though we're not defining it in this case in the init, it still would be available everywhere. As a, like a practice, it's probably, you don't have to do this, but it's probably a good idea to put this here and do something like that, because it tells whoever is looking at this class what all the properties are going to be. So if we do stuff here and we like assign properties down in these methods, looking at the class, it's not immediately clear kind of what this class is supposed to look like. So I would do something like this. We'll just set this equal. Basically, this is like telling us that this is going to be a list. And then when we actually call this method, this is going to be reassigned now. So we could do something like that. So I'm going to pretend that we didn't do that. Actually, that's fine. So this is, very half-assed test-driven development, but we're still going to write tests. So I'm going to copy that, and this I'm going to test the convert strings. So test underscore has to start with and I'm going to create an instance here, and then what's my next step going to be?
Well, assert equal might work, but you might have to go back to the documentation to figure out what to use to compare arrays.
Okay, good. So this is definitely a gotcha that we should be aware of. In Python, it happens to work out. So we don't need to worry about it. But yeah, it's definitely something to think about. But so as is right now, I've created this instance. So what is converted to list going to be?
It's a property of the CC instance.
It is. But what is the value going to be?
1, 2, 3,
and strings.
Okay, so let's test that. So cc dot converted. I'm going to make this just explicit. So this will be 1, 2. Oops. Right. So let's try running this. And we get a failure. So let's look at the output here. So we have an error, which I don't think. Right, sorry. My bad. Let's try that again. Okay, so this is what we should get. So we should get so an F for a fail and then a dot for a pass. So we ran 2 tests. The first one, or one of them failed, one passed. And here's the failing test, convert string to list, which is right here. And the assertion error is list differ. So we have an empty list. So converted here is an empty list, and it's saying it does not equal this list that we provided right here. And it gives some more detail. You can see the difference here. So what's the issue?
So we defined convert string to list, but because it's not in the dunder init, it's not actually being called. So we would have to explicitly call that method, because as it stands right now, the dunder init runs and those variables are initialized, but it's never turned into a list because at no point do we call that.
Right. So how do we do that?
I guess just explicit, just say that instance of CC call the method.
Okay.
So convert string to list. You could even, you could do it there too. Convert string to list, throw on parentheses, doesn't take any parameters. That'll run that code. So in theory, you should actually have a property to access.
Okay, let's try that. And looks like that worked. So does this make sense to everyone? This is
Nope.
okay.
Make it easier to look
No.
at. Oops, excuse me. To make it easier to look at, I normally just put all of it in one line, like converted to list dot, converted to line. That way I know I'm putting both of them together at one time to run.
Yeah, so yeah, we could definitely do that. So this is written on a separate line, but we don't have to. We could put this.
Yeah, all on one line. It
Put
just
this right
makes
here.
it easy for you to know that you ran both of them together.
Okay. So I'm gonna walk through this and then we'll see if it's any clearer. So we have this class credit check. We have this init method, which so init is just, you can think of it as a method that Python will automatically run for you when you create an instance. So when we create an instance, Python is automatically going to run this method. In order to run this method, to create the instance, Python, we're telling it, you have to pass in this parameter, which is going to be digits. And then we assign that to this instance property. So now CC, which is the instance, has the property digits, and that digits equals 1, 2, 3, which is what this test is actually testing for. So we create an instance of CC, passing in 1, 2, 3, and then CC.digits, which is self.digits, equals 1, 2, 3, whatever we passed in, right? Then we added this line. So we don't have to pass anything in here, but this method is still getting run. So now this instance has a new property called converted to list, which is just an empty list right now. So when we create this instance, just like right here, we now have two instance properties. We have digits, which is going to be whatever we passed in here, in this case, 1, 2, 3. And we also have converted to list, which is going to be an empty array. So after we run line 11, CC is going to have self.digits equals 1, 2, 3, and self.converted to list equals empty list. Then what we do is we run this method, convert string to list. When we run this method, this changes this property or variable, right? You can think of it as a variable. So we're just reassigning something here. It started out as a blank list, and then we're saying, you know what, I'm going to update you. You are now a list of that, which is going to create this, right? So we start off, it's just got this stuff when we create the instance. Then we run this method, convert string to list, which updates this, right? Then we have access to this updated property, converted to list, which is the same as this. And that equals, in this case, 1, 2, 3. Are there any questions about that?
I have a question, but it's not necessarily about that. If we're gonna keep calling CC for each method in the unit test, is there a way to just make it a variable that is like accessible once and it's automatically used, or do you
That is
have
a-
to retype it every time?
That is a great question. So you've noticed that we are repeating ourselves a lot here, right? And probably we're gonna end up doing something like this for every single test, right? So if only there was some way to, so there, it turns out there is a way for us to handle that. So this is an expected kind of thing, and this module handles that. So it's actually called setup. So there are two kinds of setup you can do. So this is called a test fixture, by the way. So what we're about to do is called a test fixture. So if you don't if this doesn't make sense, you don't need to worry about it too much. So there's a built-in method called setup, which you can run. I'll click on this to see the documentation. So setup is a method called to prepare the test fixture. Blah, blah, blah. This is called, so basically, if we want to do something before every single test is run, then we can override this. So I'm going to go here and def setup. So this is built in. I'm basically overriding something. So setup, and we're going to do self. I know this is confusing, but remember that this test that we're running is actually a class. So we want to actually assign, so self.cc equals one, two, three. And then we can actually comment out these, and we'll do self.cc.digits. We'll talk about this more in a sec. Let's run this and make sure that it's okay. And it still works. So this is an additional feature of the unit test, which you don't have to use, but as Tressa pointed out, we were repeating ourselves, and this is likely to continue. So that's a good thing to notice and to think, is there a way for me to, put this in one place instead of 50 places? And turns out there's a way to do that. You can also, there's actually a class method called setup class, I believe it's called, that runs basically once for the entire class. Here we're creating a new instance for every test, which may or may not be what we want to do exactly, but we'll leave it like this for now. So I'm actually gonna just, because I don't want to confuse people, I'm just gonna comment that out, and I'm gonna go back to this, but just so you know, that is there. Okay, so we're back here. All right, so we've now converted. So are there any questions about how this thing is working? So we call this method basically to update this variable. All right, so I'm gonna.
Sorry, I was just gonna make a comment. It helps me to think like similar to like defining functions in JavaScript. Just defining a function doesn't in itself call it. So in this case, the dunder init is the only code that's going to run unless it's explicitly called.
Yes.
So I just think of it as defining a function, but if you don't call it, nothing happens.
Exactly. So you can think of this as basically update this thing. So call this function to update this. All right. So I think that that works for now. So convert string to a list, and let's keep chugging along. So once we convert that, we need to double every other one. Should we?
I have a question.
Yeah.
Isn't it still a string though? Like string 1, string 2, string 3?
It is. It is still a string. Yeah. So there's some questions about should we keep this as a string? Should we convert it to? Do we convert them to integers? It kind of, a lot of it depends on what we want to do here. But I'm gonna, I don't know if this is simpler, but I'm just gonna leave it as a string right now. Because I'm gonna say that we're gonna need to convert to a string for this one. So we don't have to do it that way. You know, there's more than one way to do this. But what about, should we reverse this?
I don't think it's necessary to reverse it. We'll just have to be mindful of that when we start going through it.
Okay. So it's possible, so we could either reverse it or not. So again, there's lots of different ways we could do this. You can think about what makes sense, but we'll just keep going like it is for now. So I'm going to I'll copy this one. All right, so double every other. So we're going to convert the string to a list, and then double every other. How do we want to handle this one?
Can you set up a, well, when I did my code, I kind of, what did I do for the double? I looped through the range backwards. And then if it was modulo 2, it was an even number, odd number. That's how I figured out which one to double.
Okay. All right. Has anyone used a list comprehension before? This is.
I think I ended up using it for this one.
Okay. So list comprehensions are something that exist, don't exist in JavaScript, exist in Python and some other languages, but it's basically a way of kind of running a for loop and creating an array at the same time, or creating a list at the same time. So you could, the typical way to do that is you create an empty list, and then you have a for loop, and then you add stuff to the list, and that's fine. I think we all know how to do that. So I'm going to show you another way of doing that. So to keep things simpler, I'm actually going to go ahead and reverse this. So convert string to list, and I'm going to add a so I'm gonna add a method here, and then I'm gonna add this may be a reserved keyword. So I'm gonna reverse this. So whatever this is, self dot converted to list. So there's easy syntax for this in Python.
Mhm.
So you can do this. Has anyone seen this?
Yes.
So can you tell me about this?
I don't know what to do. I was just searching
Okay.
Online reverse the string and I found it. But basically, if I understand it, it's kind of like doing the length, going from the back to the length, kind of like in a JavaScript. If in JavaScript it's array.length -1. So I'm
Right.
assuming those two dots would kind of stand for the actual array
Right.
-1.
Yeah, so good. So there are actually 3 slots here separated by colons. The first 2 slots are empty, which means they're going to use the default values. So in this case, -1 means where you start from, basically, or the step, right? So we have start, stop, and step. So start means I'm going to take a slice. I'm going to take a slice of this array, and I'm going to start at the very beginning. So that's the default. So I'm going to start at the very beginning, and I'm going to go to the very end. So this start, stop, they're both defaults, which means start at the beginning and end at the end. So basically take the entire list, and then step is -1, which in this case just means backwards. So you could skip, if this were 2, then it would, skip every other one. -1 is backwards.
So can we skip a step and just put that in -2 and then just be our array with every other number?
You could, but it's not going to pick up. So we want to preserve all of the values.
Okay. In those 2 spaces where the dots at, say if I wanted only part of the array, could I change those dots to numbers?
Yeah.
Okay.
Well, you do something like this. So if you want to start at the first and go to the third or something like that.
Gotcha.
Okay, but this is just syntax. The basic idea. The basic idea is the same. So I'm going to call. So I'm going to convert this to a list, and I'm going to call. So again, we're entering territory where now things are maybe like, you might want to rethink how we're designing things and how someone is going to actually use this class, but we're going to keep going as it is for the sake of time. So cc dot blah blah blah, and then cc dot reverse rev. So I'm going to call this, and that's going to update this property right here, reversed. And then when I double every other, I can use this reversed array. So I'm going to start there. So self dot reversed. And I want to use a list comprehension just to introduce them. And they're also very common in Python, so you should become familiar with them. So the way this works is we're basically going to create an array. And we're going to write the for loop or list. List and array are same thing. We're going to write our for loop basically inside of this list. So we'll do something like D for digit for D's in self.reversed. So this is like a for loop. So for all of the elements in this reversed array, D is going to represent each one of them. And in this case, it's going to create a new array. So this right here is creating a copy, essentially. It's saying for every digit in this array, append this digit to this array. So it's basically just creating a copy. But we don't want to make an exact copy. We want to modify every other one. So we're going to need a condition here. So D if D T modulo 2. Actually, yeah, sorry.
That's the digit rather than the index. Wouldn't it be the index modulus 2?
Yeah, you're right, sorry. So we're gonna have to do is, instead of just self.reverse, this is gonna give us access to every value there. We also need access to the index. Does anyone know a way in Python where we can access both the index and the value?
Enumerate.
Yes.
Enumerate.
Enumerate.
We can do that. So now we have the index, right? So we can print this. Let's print this. Let's see. I'm going to go down to the bottom and I'm going to create, so this is just some ad hoc testing real quick. So CC equals 1, 2, 3 and CC dot string to list and CC dot see, gotta call reverse, and then we'll call CC dot. All right, so Python and check. We have a reversed string right now, but this is basically a copy. So we have the reversed string, and we're enumerating it, and we could actually take both of them. So let's look at the indexes as well. So now we have a list of tuples. So the first element is the actual value, so 3, 2, 1, and the second part of the tuple, second element in the tuple is the index. So what we want to do is we want to take the number if I modulo 2 equals 0, we're going to double this. So list comprehensions are great. They can get a little complicated. Let's see what this one gives us. I have to put this. So the order of the conditionals is, oops, let me try this. May have to put the conditional in a different place. Okay. All right, so what problem am I running into now?
They're not integers.
It's not multiplying.
Yeah, so I have an array or have a list of strings and I want to double them and I can't. If I double, then this is an overloaded operator. So it will do different things depending on what type I pass in. So if I pass in a string, it will, it'll do this. It'll like, clone it. If I pass in an integer, it'll actually multiply it. So what do I have to do to fix this?
Put int and then put it the variable in parentheses.
Yeah.
That will change the type from string to integer.
Actually,
so int open parentheses.
One sec. I don't know what happened there. So I just can't remember. LSD. There we go. Sorry. So you can actually have a lot more complex list comprehensions where you have like for loop inside of a for loop, and the syntax is a little strange. You need to put the conditionals in another place depending. But anyway, so this is now what it's supposed to be doing, except that we have strings. So we have to convert this. Let's convert this. So int, you can cast the string to an int. I'll go ahead and do. So this is, we have to do this because of our decision earlier to keep this as a list of strings. So we could go back and modify that if we wanted to. Again, lots of little decisions to make. And we get 622. So the first one is double. I think we need to do. So we don't want to do every other one, right?
Then modulus 2 not equal to 0.
Let's try that. So 3, 4, 1, right? So I think this is the behavior. Thank you. So 3, 4, 1, and then if we had another one, hopefully it'll be doubled. All right, so let's. So we have this. It's a little hard to see, but this is a list comprehension. So I'm going to assume that doing this in a normal for loop would be fairly straightforward, but this is what it looks like in a list comprehension. So then the question is, what do we want to do with this doubled every other thing? Do you want to just return it? Do we want to assign another variable here?
I guess I would just return the array. So you're happy with those values, they're all integers, and then worry about splitting the 2-digit numbers in another method.
Right, yeah, so we do have another method for that, right?
Oh, yeah.
But there's a question of what do we do with this value? So the pattern we've been following so far is basically create an instance method. So we keep doing that. We also might want to rethink what we're doing and how this is designed, but I'm going to go ahead and do that. All right, and then double every other. So now let's implement this test. So 1, 2, 3, I'm going to add a 4 just to make sure. So convert the string to a list, right? You have to convert it to a list, and then we reverse it. And then we call double every other. And then we can check this doubled. So cc doubled, and that should be equal to, what was it, 3, 4, 1. Actually, no, that's wrong. It'll be, so 4, 6, 2, 2, I think. Let's see if that is. Okay, so 4, 6, 2, 2. Right. Okay, so that test passed now. So I'm not going to do the rest of it. This has gone on actually quite a bit longer than I anticipated, but that's the basic idea. So the rest of this could be finished, I think, pretty straightforwardly, but we now have kind of a one-to-one correspondence between tests and method. We could test all of this individually. We could also pull it apart. But there are questions. I know we've just started looking at classes, but there are, lots of different ways to design a class. It kind of depends on how you want to use it and what you want access to. So for example, if we wanted each instance to preserve the history of every transformation it did, that may be something that we want, then doing something like this might be a good idea. Otherwise, it's possible that we're just kind of wasting space, saving a bunch of old information that we don't need anymore. So just something to think about as you're designing this. But in terms of testing, I think it's pretty straightforward. It shouldn't be conceptually any different than what we've learned before. It's just a matter of how this particular library, unit test library, does it. All right, any questions?
I have one question.
Sure.
At the top, where you have your from statement, from credit checks, import credit check.
Yeah.
That first credit underscore check, that's just a word that you made up. You can call that anything.
Well, this is the file name. So it could be anything, but it has to match this.
Gotcha. Okay. I was trying to see where that name came from. Okay.
For the future challenges that we're working through, should we get in the habit of trying to use class for everything instead of just like in the past when you were just using regular functions?
I would say for now, yes, I would do that, just to get used to using classes. Are classes always the best way to solve everything? No, but again, since it's new, I would say try the new thing until you become comfortable with it.
Okay, thank you.